Next question for electrostatics, question 10, page 213. The dipole moment of a water molecule is given as 6.3 into 10 raised to minus 10 coulomb meter. This is given to us in the question. This is a dipole moment. Now, please remember dipole moment is denoted by P, small p. This is coulomb meter and not centimeter. So, capital C, it should be capital C here. Capital C and small m is a coulomb meter. Capital C and small m is coulomb meter. So, dipole moment is given. So, I can say that P is given 6.3 into 10 raised to minus 30 coulomb meter. A sample of water contains 10 to the power 21 molecules. 10 raised to 21 molecules is given to us in the question, whose dipole moments are all oriented in an electric field of strength 2.5 into 10 raised to 5 Newton per coulomb. Electric field 2.5 into 10 raised to 5 Newton per coulomb. Calculate the work done. Calculate the work done to rotate the dipoles from their initial orientation theta 1 is 0 to one of the dipole with the perpendicular to the field, that is theta 2 equal to 90. So there are two conditions given. So we have the formula work done is equal to PE cos theta 0 minus cos theta 1. This is the formula. The work done for a dipole is given by this formula, W equal to PE cos theta 0 minus cos theta 1. Theta 0 is the initial condition, theta 1 is the final condition. So I can rearrange this formula and write, I can rewrite this formula as W equal to PE cos theta 1 minus cos theta 2 as given in the question. So since there are n molecules, for n molecules, the formula will change a little bit. W will be equal to n PE cos theta 1 minus cos theta 2. This will be the formula. So now let us just substitute the values. In case of n will be the number of molecules. The number of molecules is given as 10 raised to 21. So W will be equal to 10 raised to 21. Dipole moment is given 6.3 into 10 raised to minus 30. Electric field 2.5 into 10 raised to 5. Cos theta 0, that is cos theta 1 is given cos 0 minus cos 90. So we know that W will be equal to 10 raised to 21 into 6.3 into 10 raised to minus 30 into 2.5 into 10 raised to 5 into 1 minus 0. Cos 0, 1, cos 90 is 0. When you solve this, you get the correct answer for the work done, that is 1.57 into 10 raised to minus 3 into 10 raised to minus 3 joule will be the answer. 1.57 into 10 raised to minus 3. A charge 6 microcoulomb. This is number 11. Sum number 11. A charge 6 microcoulomb is placed at the origin and another charge of minus 5 microcoulomb is placed on the y-axis at a position 0, 6 meter. So you can see over here, this is at the origin. I have a charge at this origin, 6 microcoulomb, and there is 5 microcoulomb at a 0, 6 meter. That means this distance is 6 meter. It is given in the question. By geometry, let us join these 2 points A and P. Let us join these 2 points A and P over here. So if this is 6, calculate the electric potential at P whose coordinates are 8, 0. That means this distance is given as 8 meter. So if this is 6, this is 8, by Pythagoras theorem, this will be 10 meters. 6, 8 and 10 are Pythagorean triplets. So I have got one triangle. I have got one triangle in this way. If I draw this very carefully, this is point P. This is point of no point is given. Let us take it as O as origin, where 6 microcoulomb is there. This is 8 meter, this is 10 meter, this is 6 meters, and this is point A, where there is a charge of minus 5 microcoulomb. So this is the triangle which has been formed from the diagram. Calculate the total electric potential. Total electric potential, why is the word total? Because there are two charges. One is 6 microcoulomb positive charge, other is minus 5 microcoulomb negative charge. So total electric potential. So the first part of the question A, total electric potential due to charges 6 microcoulomb and minus 5 microcoulomb is given by V equal to 1 by 4 pi epsilon naught. The first charge Q1 upon the distance R1 divided by second charge Q2 upon R2. So I have 1 by 4 pi epsilon 9 into 10 raised to 9. Let us assume the first charge Q1 is positive charge. 6 microcoulomb, 6 into 10 raised to minus 6. It is at a distance of 8 meters to P, point P. I need to find at point P, so I'll take that distance. Minus, why I'm writing minus? Because next charge is minus charge, minus 5 microcoulomb. So micro means 10 raised to minus 6. Divided by that is at a distance of 10 meter till P. I need to find it till P. So O to P, that is 8 meter, A to P, that is 10 meter. So when you solve this, you get 9 into 10 raised to 9 in bracket Q1 upon R1 and Q2 upon R2. When you solve this, you get the answer as 2.25 into 10 raised to 3 volt. That will be the answer. That is a potential difference. Second part that the question is asking, the calculate the work done to bring a proton from infinity to the point P. So for second part, I'll write here, the work done to bring proton from infinity to point P will be given by W equal to minus QV. Now here why minus, why here negative sign? Negative sign indicates it is for the charge. We are bringing a negative sign. It is because of a charge which has been moved. Which charge has been moved? Proton. Proton is a positively charged, right? So there is a positive charge which is moved against the electric field. That's why there is a minus sign. So W will be equal to minus charge of proton 1.6 into 10 raised to minus 19 into V potential 2.25 into 10 raised to 3. So when you solve this, you get the answer minus 5.4 into 10 raised to minus 16 joule. You have to write the significance of minus sign. The negative sign indicates that positive charge is moved against the electric field. So negative charge in the negative sign indicates that the positive charge is moved against the electric field. Next question 12. In a parallel plate capacitor with air between the plates, each plate has an area of 6 into 10 raised to minus 3 meters square. This is given to us in the question. The area is given to us in the question. Area A 6 into 10 raised to minus 3 meter. Separation between the plates is given. D is the separation, that is 2 millimeter. That is 2 into 10 raised to minus 3 meter. Calculate the capacitance. So since it has air between the plates, for air, remember the dielectric constant K is 1, or you cannot take the dielectric constant, even that is okay. We have the formula for capacitance of a parallel plate capacitor without dielectric. That formula can be used. And the formula will be C equal to A epsilon naught upon D. A is the area, that is 6 into 10 raised to minus 3 multiplied by 8.85 into 10 raised to minus 12, that is epsilon naught value, divided by D is 2 into 10 to the power minus 3. So when you solve, you get the answer. So the answer for the first case will be 2.65 into 10 raised to minus 11 farad. That will be the answer for the first case. Second case is asking if this capacitor is connected to 100 volt supply. So V is given 100 volt. What would be the charge on each plate? That is Q is being asked. So I know that Q equal to CV. This is the formula. Here this is the formula. C equal to A epsilon naught upon D. So here C I have already calculated in the first case. That value I have to take. That is 2.65 into 10 raised to minus 11. V is 100. 100 I can write 10 raised to 2. 100 can be written as 10 raised to 2, and 2 minus 11, that will be minus 9. So I can write 2.65 into 10 raised to minus 9 coulomb. So no need to multiply or solve. That is simple one. For third case, I have a dielectric constant of thickness which is 2 millimeter thick. 2 millimeter, again 2 into 10 raised to minus 3 meter, with a dielectric constant K is of 6, which is inserted between the plates. How would the charge be affected? So I need to find Q value. If V remains the same, V is 100 volt. But before I find Q, I will have to find the value of C also. So either I can do one thing, I can directly do Q equal to CV will be the formula. So C ke liye what will you do? Q equal to, now here there is K which is inserted. So A K epsilon naught upon D, that is the capacitor value into V, right? So our total formula will be Q will be equal to C into V, but the C value will be this, A K epsilon naught upon D. C is A K epsilon naught upon D because here dielectric is inserted. So when dielectric is inserted, you will use AK epsilon naught upon D. When dielectric is not there, you use this relation. Now put the value. So Q will be equal to area, and D will be the same as you have taken in the first case. 6 into 10 raised to minus 3 into 6 into 8.85 into 10 raised to minus 12 into voltage is 100 divided by D. D is 2 into 10 raised to minus 3. So just solve this. You get the answer for the charge, that is 15.9 into 10 raised to minus 3 coulomb. That will be your answer on solving this. Last question for the chapter. Find the equivalent capacitance between P and Q given the area of the each plate A and separation between the plates is D. So you can see there are two figures. I'll write this as figure 1 and I'll take this as figure 2. For these two figures, I need to find the capacitor. So first case, if you see, this is just a capacitor in series combination. When capacitors of n dielectrics are connected in series combination, so that is given by C equal to A epsilon naught upon T1 upon K1 plus T2 upon K2 plus T3 upon K3. That is the formula. So C will be equal to A epsilon naught. Area will be as it is A only. That is given. Area is A epsilon naught divided by T1. First thickness D by 3 upon K1 is 1 plus second thickness D by 3 upon second dielectric constant is 3 plus third thickness D by 3 divided by third dielectric constant is 6. I'm solving for the first case, for the first figure. So when you solve this, you get A epsilon naught upon, you can take D by 3 common. Here you can take the LCM. The LCM will be 6 here. It will be 6 plus 2 plus 1. So this will be equal to A epsilon naught upon D by 3 into 9 by 6. So when you solve this, you get here 1, here will be 3, here will be 1, here will be 2, 2 will go up. So 2A epsilon naught divided by D is your answer for the first case. For the first case. For the second case, if you see, there are two different combinations. One is in series, other is in parallel. So this combination is in series combination and these together are in parallel combination, right? So first I will solve it in series combination. So for second case, C will be equal to A epsilon naught upon, I'll give it a C dash name. I'll write here, since here K2 and K3 are used, I will write T2 upon K2 plus T3 upon K3. I'm just solving for the half part, this half part. I'm just solving for this half part initially. I'm not solving for this part, only this half part I'm solving. So when you just solve for the right hand side part of the particular diagram, so what do you see? There are two dielectric constants. The area is A by 2, thickness is D by 2, right? Area is A by 2, thickness is D by 2. So in the thickness will be taken as D by 2 and dielectric constant 3 and 6. So this will be A by 2 is the area divided by epsilon naught and D by 2 upon 3 plus D by 2 upon 6. So this will be equal to A by 2 epsilon naught divided by D by 2 common. Again, I can take LCM as 6. Here will be 2 plus 1. So that will be this 2 getting cancelled. A epsilon naught upon D, this will be 3 by 6. 3 2s are. So this will be 2A epsilon naught upon D. This is the first case. I've just solved this right hand side part. For this I have got 2 epsilon naught A by D as the answer. I need to solve this part also. So this part I will use C double dash. So C double dash will be equal to A epsilon naught upon D. A K epsilon naught upon D, this formula. And area is given as A by 2 epsilon naught. K is given as K1, I can write, that is given as 4 divided by D is given as B only. So this is again 2 1s are 2 2s are. So this is again 2A epsilon naught upon D. So for this part also I have got 2A epsilon naught upon D. I need total. So total C equal to C dash plus C double dash. So 2A epsilon naught by D plus 2A epsilon naught by D, that will be 4A epsilon naught by D. That is your answer. So this ends with the electrostatics chapter numericals. So this much was for electrostatics chapter.